Imagine we were given a number like 20, and we are told that 20 is rounded to the nearest centimeter. How would we find the upper and lower bounds? Is exactly what I'm about to show you right now. So we draw our number line, as you can see I've drawn there, put 20 bang smack in the middle, and on the either end we put 1 centimeter below 20 and 1 centimeter above 20 on the other side. Now we need to create something known as an error interval. And how we do this is we look halfway between our lowest point on the number line and 20, which is going to be here. So 19.5, and between 20 and 21, we have 20.5. Therefore, our error interval is 19.5 is greater than or equal, or less than or equal to 20, sorry, and less than 20.5. And this is our error interval for 20 to the nearest centimeter. So if we were to think about this, all values from 19.5 upwards to 20, so all these values here, 19.6, 0.7, 0.8, 0.9, will all round to 20, including 19.5. And all values between 20 and 20.5, as you can see from this part, will also round down to 20. So 0.1, 0.2, 0.3, 0.4. However, 20.5 will round up to 21. Therefore, the error interval has the form of the first lower bound being less than or equal to the 20 and the upper bound being strictly less than 20. Okay, so by definition, our lower bound tells us the smallest possible value a number can take before rounding to the next step, or the largest value, and the upper bound tells us the largest value that the number could take before it would round up to the next step and value. This is a way to remember how to conduct our intervals. So 21 centimeters to the nearest centimeter. We draw our number line as 21 right here. On either end, we do a centimeter either side. Draw our midpoints from both sides to get 20 and 21.5. And here, this is now known as our lower bound. This is our upper bound. So, to write our error interval, remember we can write this as 20.5 is less than or equal to x, which is less than 21.5. Okay, now looking at a slightly different example, we're told to work out 530 to two significant figures. We need to write the upper and lower bound. So, when it comes to significant figures, we look at the last significant figure, and in this case, it's in the tens. So we can write our number line like such and get 530. And now we notice, so now we have our tens as our last significant figure. So we then half our tens to get 5. That's obviously going to give us 5. So we add 5 onto both sides of our error interval timeline, and we get it to look something like this. We then draw our midpoints as we did before to get 5 to 7.5 and 5 to 532.5. And this is our lower bound and this is our upper bound. Okay, looking at some questions, it tells us the length of a stick is 15 centimeters to the nearest centimeters. We need to find the lower and upper bounds. Okay, first off, we start by drawing our number line and we put 15 right in the middle. We notice that it tells us to the nearest centimeter. So on either end, we add on a centimeter each side to get something like this. We then fill in our midpoints left and right and get this side to be 14.5 centimeters and this side to be 15.5 centimeters. So our lower bound is equal to 14.5 and our upper bound is equal to 15.5 centimeters. Don't forget your units. It then tells us that a road is 1.32 kilometers long. Okay, so looking at our question 2, it tells us that a road is 1.32 kilometers long to 2 decimal places, and we need to find the lower and upper bounds of 1.32. So we notice that it's to 2 decimal places, right? So what we can do is write out our 1.32. Now this is a technique that I've used in many questions like this. We write out 0.00. Now we notice that the number in question cuts off after 2 decimal places. So in the third decimal place point, we put in a 0.05. So on our timeline, we get 1.32 to be there, and on either end, on the positive direction, we add, in the left hand side direction, we minus to get 1.325 on the right and 1.315 on the left. Now, once again, we do our midpoints to get 1.3175, and this side's going to be 1.3225, and that is our upper bound and lower bound. Sorry, lower bound and upper bound. Okay, now looking at this type of question, we're told that a mass of a parcel is 7.8 kg to the nearest 0.1 kg. Write down the inequality showing the range of possible values. So we know that our middle part of our timeline is going to be 7.8 kg. Adding on 0.1 kg to both sides, we get 7.9 kg on this side and 7.7 kg on this side. Finding the midpoints, we have 7.75 kg and 7.85 kg. So our inequality will look something like this. Okay, it tells us our car speed is given as 120 kilometers per hour to 2 significant figures. Remember, when we're to 2 significant figures, we notice that the last significant figure is in the tens, right? It's in the tens. Therefore, we do 10 divided by 2 to give us 5. So when we draw our number line, we're going to have 120 down the middle, adding 5 on both sides. We get 125 as our upper limit and 115 as our lower limit. Finding the midpoints, we have 117.5 and 122.5. And this is our lower bound, this is our upper bound. Okay, that's going to conclude today's video on lower and upper bounds. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video. Peace.